Welcome you all. In this session, we are going to discuss how to estimate the air gap length in synchronous machine. So, air gap length. The length of air gap is very important parameter as it generally affects the performance of the machine. Air gap of synchronous machine affects the value of SCR, short circuit ratio, and hence it influences many other parameters. Hence, the choice of air gap length is very critical in case of synchronous machines. So, the advantages of air gap length. The length of air gap generally influences the performance of synchronous machine. So, let us discuss the advantage one by one. First one is the stability. Higher value of stability will be there. Regulation, smaller value of inherent regulation. Synchronizing power, higher value of synchronizing power. Cooling will be better. Reduction in noise, smaller value of unbalanced magnetic pull. So these are the advantage with respect to having the higher value of air gap. So the disadvantage is the disadvantage of larger value of air gap is required the field MMF will increase and the resultant of large field winding. So that's the very first point. Field MMF. Larger value of field MMF is required. Size, larger diameter and hence larger the size. Increase the magnetic leakage. Higher weight of copper in the field winding and the cost increases. Hence the length of air gap must be selected by considering the above factors. So let us see how to estimate the air gap length. The length of air gap is usually estimated based on the ampere turns required for the air gap. Armature ampere turns per pole required ATA is equal to 1.35 T phase kW per pole, where T phase is turns per phase, I phase is current per phase, and kW is winding factor and P represents the poles. No load field ampere turns per pole ATF naught is equal to SCR short circuit ratio into armature ampere turns per pole. So it can be expressed as ATF naught is equal to SCR into ATA. Suitable value of SCR must be assumed. Ampere turns required for the air gap will be approximately equal to 70 to 75% of no load field ampere turns per pole. Air gap, MMF at the air gap ATG is equal to 0.7 to 0.75. That is what I mentioned in the previous point. That is 70 to 75% of no load field ampere turns. That is ATF naught. The air gap ampere turns ATG is equal to 8 lakhs BG kg LG. So with the help of this expression, LG can be calculated. We know the value of ATG, then we know the value of BG and kg. So on substituting the value of BG and kg, we get the value of LG as ATG divided by 8 lakhs BG kg. This is the value of LG. So and BG is equal to B average by KF. By substituting the values, we'll be getting the value of length of air gap. So the air gap coefficient or air gap contraction factor may be assumed by varying from 1.12 to 1.18, assuming as a guidelines the approximate value of air gap length can be expressed in terms of pole pitch. So for silent pole alternator, the length of air gap LG is equal to 0.012 to 0.016 of pole pitch. And for turbo alternator, the length of air gap LG is equal to 0.02 to 0.026 of pole pitch. So synchronous machine are generally designed with larger air gap length compared to that of induction motors. And for silent pole machine, normally construction length of air gap by pole pitch is equal to 0.01 to 0.015, and for synchronous motor it will be length Lg by tau is equal to 0.02. So using those relations we can select the value of Lg such a way that it gives a higher good performance of machine. Thank you.